All right, no, do not worry about emailing me about questions. You are so good. What I'm gonna do is I'm gonna assume that you are gonna learn from this, but if you need more questions, let me know. So I'm gonna give you the points for it, because I don't feel like I should make you go back, and redo it just for this. But like I said, if you want more questions, let me know. Just a heads up, we're gonna do a project instead of a test. And so it will be open, no, open, so I'm not as concerned about the test, so that's why I'm giving you these points. So just a heads up, I'm gonna give those to you, so some fudge points there, but make sure that you do understand what I'm gonna show you, okay? So number two, I'm not sure your strategy, and I think you just made maybe addition or something mistake, but the strategy that I like to use is just get rid of the fractions. And if you remember from the teaching video, I said that you could just multiply by the least common denominator to everything. And as you hopefully remember, when we do that, that'll make a 6a, a here, right? And so those a's cancel, and then we have 6a equals 3a plus 6 plus 1. And so we don't have the denominator to worry about anymore. And when we distribute it to every part, we're being equal and fair. And since it's an equal sign, we're fine. So if you have any questions on that, let me know. Then all we have to do is just treat it like a three-step equation here. So we have 3a equals 6 plus 1 is 7. We'll divide by 3. And we have a equals 7/3. Okay. All right. And then the next one, I did have a typo, but the typo shouldn't have ruined your math. But you ride your bike to the movies 5 miles away when there's no wind. When there is no wind, you ride at 6 miles per hour. Today, your trip to the movies and back took you 3 hours. What was the speed of the wind today? And I don't know if I did an example of wind, but we did an example of the river current, which is kind of the same idea. So you're traveling 5 miles, and you have your rate, 6 miles per hour. So time equals distance divided by rate. That's where this is coming from. But we're going to have wind at one point helping us, at one point hurting us. We're assuming that this wind was constant all day because the problem didn't specify otherwise. So we are taking a lot of just assumptions here. Plus, we got to come home, and I'm assuming the wind is going to take away from our speed, and that's why it took us 3 hours. All right, so yeah, we're assuming that the wind hasn't changed while we rode to the movies, while we're at the movies, and then when we ride home. So 6 miles per hour plus the wind helping us, 6 miles per hour plus the wind making us go slower. Now, it doesn't matter which one's going there, which one's going back, because we're adding. If we mix up the order, it's okay. And it didn't specify, so we're good there. And then I like to do the same strategy as before. I multiply everything by 6 plus w times 6 minus w. And so that will cancel out this, right? 6 plus w will cancel that out, but leaving me with 5 times 6 minus w. And then that will cancel out there when I distribute it, leaving me with 5 times 6 plus w. And then as I distribute here, it'll be 3 times 6 plus w times 6 minus w. And then I'll distribute that, and I'm going to get 30 minus 5w plus 30 plus 5w, which cancels those out and leaves me with 60 on the left-hand side. And then I'm going to hold off on that 3, and I'm going to remember I have difference of squares here. So 36 minus 6w plus 6w, so I'm going to have 36 minus w squared. And now I'm going to distribute that 3. 3 times 36 is, 3 times 6 is 18, carry the 1. 3 times 3 is 9, 10. I have 108 minus 3w squared. And now just solve, right? So minus 108, minus 108. And that's going to give me negative 48 equals negative 3w squared. divide by -3. That'll give me 16. And then I got to get rid of my square root. And remember that causes a plus or minus, which we don't really care about the negative because the wind's going to be 4 miles per hour. And so the key kind of is, it's kind of like that current, and just imagining you're riding your bike in the wind. Yeah, it's going to make you go slower, or it's going to make you go faster if it's to your back. Now, like I said, we're making a lot of assumptions about this. If we were to be more exact, like what direction's the wind coming from? Does it change? It would change the problem, but yeah, so there it is, kind of like the current. Hopefully that helped. If not, let me know and I'll try again.